So dilations. It's enlargement if k is bigger than 1. It's reduction if k is between 0 and 1. If I had a scale factor of 0, what would that mean I did to the figure? I shrank it till it's gone, right? I can make something 1/100th of the size, 1/1,000,000th of the size, but I can't make it 0th of the size, can I? So that's why scale factor got to be between 0 and 1. Scale factor, you always take something from the image divided by something from the pre-image. We're going to start by dilating triangle ABC using center P and a scale factor of 2.5. So I'm going to make P right here, and I'm going to draw a triangle. A, B, and C. Now this is so hard. Oh Lord, Mr. Kuhne, I don't know if I'll be able to do this on my own. Watch me for the first one here. Pencil down. If I want to dilate something, I want to make it bigger, don't I? 2.5 times bigger, 2.5. So what we're going to do here is we're going to measure from here to here. I'm going to measure this, and I get 6. So I'm measuring from the center to point A. Center to point A, and I get 6. Guess what I have to do to that 6? Absolutely correct, man. Multiply it out. You rock. So I'm going to take this 6, multiply it by 2.5. 6 times 2.5, the scale factor. 6 times 2.5 is 15. So what do I do now? I go from here. Which way should I go? Do I go up like this? No, I go right through the A, don't I? So I'm going to go out to 15. So that's 15. And I put my A prime. That's it. That's it. That's how easy it is. Let's measure from. I'm going to measure from P to B, and I'm going to get here. Looks like 8.5. So this is 8.5. So 8.5 times 2.5. Let's see here. 17. 21, 21.25. So I go out here, 21.25, please. My math might be wrong there. I put B prime. So this whole thing out here is 8.5 times 2.5. And I do the same thing for C. Here to here is 4. That's 4. So 4 times 2, 4 times 2.5. It's going to be 10. So I go out here, 10 units. Make my dot. And I just have to connect them. Does this white thing, does the yellow thing look like it's 2.5 times bigger, approximately? That's it. So, I'm going to give you a few minutes here. Do this with your teammates. I will come around and help as needed. Go ahead and begin. We have, so our image, it should be 2.5 times bigger. I'm just going to do some measuring to check. AB looks like it's 5.5. 2.5 times bigger. Looks like 14. Sounds about right. Here's just a little bit off. It's okay. 7. 7 times 2 would be 14. Then half of 7 would be 17.5. So this should be about 17.5. 15, 16, 17.5. It's 2.5 times bigger, isn't it? Also, now also just kind of for the artsy people, hey, if I were to get rid of the numbers in here, that just looks kind of cool too, doesn't it? Kind of a cool looking design there, don't you? It's like a kite, pyramid, something like that, yeah. In art, these are vanishing points. You've done the whole hallway thing before, right? Same thing. Same basic idea. All right. So that's how you dilate just using pencil and paper. Now, what if we have to dilate on a graph? We'll do that now. So we're going to have the coordinates over here. My old work here. We're going to dilate this around the with the origin as the center. So here's my point P. Then all we're going to have to do is, well, what did we do in the last one? We took the distance and we did what with it? Made it 2.5 times bigger, right? Here the K is 2/3. So guess what we're going to do to everything in here? Multiply by 2/3. That's it. We're going to take every single coordinate up here and multiply it by 2/3. So let's start with, we'll actually start with, no, we'll start with C here. That's fine. So C is 0, 4. I'm going to take the 0 times 2/3 and the 4 times 2/3. All right, well, 0 times 2/3 is still what, everybody? 1, 2, 3. And 4 times 2/3, I don't need a calculator for that, do I? Because I know that's 4 over 1 times 2 over 3. If I multiply, well, that's going to be 8/3. Now you may be saying, Mr. Kuhne, I don't know how to multiply by 8/3. That's fine. Let's change it into a mixed number. 8/3, 8 divided by 3 would be 2, give me 6, 2 left over, so it's going to be 2 and 2/3. So my coordinates here are, for A, 0 and 2 and 2/3. So I go 0 over, and then up, 1, 2, and then I got to break it up into thirds, don't I? 3 parts and 2/3, right there. That's my C prime. We're going to take A, take all the coordinates times 2/3. Take B, take all the coordinates times 2/3. 2 minutes. Find the coordinates of B prime, C prime, and graph them. Do it with your partners. Go. So, to find A prime, we got to take the coordinates 3 and 9. Take each one times 2/3. What'd you get, ma'am? Should be 2,6. Should be 2,6 for A prime. So take 3 times 2/3. And then 9 times 2/3, I get 6. B. What's B prime going to be? No, anybody? 5 times 2/3, well, that's 5 over 1. That gives me 5 times 2 is 10 over 3, so 10/3, which is 3 1/3 if I make it to a mixed number. 3 1/3. And then 6 times 2/3, that's going to give me 12 over 3, which reduces 4. Yep, 4. So we're going to have 3 1/3. Well, I can divide that up into 3's, can't I? And so 3 1/3, and then 4. 1, 2, 3, 4, right there. That's my B prime. And then I got 2 comma 6. That's my A prime. So if I graph this, that's my image, my pre-image. I didn't want to get too much on there, confuse you. It was right there. Does that look smaller? Yeah, and it is smaller. It is smaller. So, that's how you dilate. Just take every single coordinate times the scale factor. 3 times 2/3, 9 times 2/3. So it's 5 times 2/3, 6 times 2/3, 0 times 2/3, and 4 times 2/3. Questions? This is also how projectors work. Anytime you use projectors, you have the pre-image right here, correct? And then light comes up, it focuses into here, then it starts coming out. The farther you are away from the point, it's going to be bigger, or if it's really close, it's going to be small, right? Same thing here. The farther we are away from the point, it gets bigger. The closer we are, it gets smaller. So that's how projectors work. All right. Go ahead and get started on your homework.